Department of Mechanical Engineering for securing fund to organize 5 days Atal FDP. I take this opportunity to extend sincere gratitude to our patrons and beloved principal sir, Dr. Mohan Babu, for their immense support in organizing such programs.
For a teacher, upgrading the knowledge is the most essential. Otherwise, it will become an absolute over the years. One day, we were discussing in a meeting to update the knowledge of the teachers on the upcoming areas. Many of them have suggested the different areas. One such area, what we thought to have more opportunities to possess the research, to contribute something for the nation, is the hydrogen. Why hydrogen? In fact, to say this, hydrogen engines were invented in 1820 itself. But with the later invention of internal combustion engines by a great scientist, Otto has invented internal combustion engine with the use of fossil fuels available, petrol and diesel. Petrol and diesel took the market over the hydrogen engines. So that invention was stopped there itself. So after that, hydrogen starting the use, people have started in the aerospace and rockets to use the fuel as hydrogen because of its higher weight to energy ratio. This is the first thing. Apart from that, in industries, use of hydrogen is, lot of hydrogen is used. Millions of tons of hydrogen used even in India, across in the industries also. So this, after some years of this, we are using last 100 years the fossil fuels. Now, because of continuous use of this, there are 4 elements, basic elements: hydrogen, carbon, nitrogen and oxygen. The compounds of these elements plays a very important role for the on the earth here. Either they are harmful, some of the gases are harmful, some of the compounds are very useful. So in that way, now the United Nations is recommended 17 sustainable goals. One such goal is climate change, immediate octane climate change. That is goal number 30. That is also recommended. The purpose of this goal is to decarbonize the surface, Earth, decarbonize the surface of the Earth. The meaning is, no other planet is supporting the human being or livelihood or to grow any of the plant. No oxygen, no water, except the Earth. We have to save this Earth for the next generation. Otherwise, human being will never survive on the Earth. Keeping this in mind, governments have started introducing continuously to go for a cleaner air and to reduce the decarbonizing. For that, the government has started stringent regulations on pollutions. And also, with the interest of some of the scientists, they have started reducing the tendency of using the biofuels. With these 3 concepts, people have started an alternate fuel, hydrogen. That is the only possible way we can decarbonize the engine with a strategic plan. And this is one of the sustainable goal of the United Nations.
This topic, while I'm going to have a little more detailed discussions in the coming session, you have to listen to me, you have no choice. Okay? And he brought about very important issues with respect to emissions and related aspects. And as mankind, I think we have started with the very, very natural available material called wood, which was there as a fuel. And the greed with which the human beings started using that to exploit to the other extent in terms of the same biomass or whatever maybe agro residues which were there, they became fossil fuels with time. I think millions of years it has lasted in below the ground, and today, not to meet our all energy needs, we are trying to exploit that to the limit. because of which the rate at which the so-called utilization of the fossil fuel is happening, which is a typical hydrocarbon. When you burn a hydrocarbon, it results in hydrogen and CO2. And people have been talking about climate change. Yes, one of those components which contribute towards the climate change is the CO2 which is there. That means the amount of carbon dioxide what you are putting into the environment with time is raising the so-called the average temperature across the globe. I think that has been a concern, because of which you have various things what happen across the globe. One is maybe people have been talking about Himalayas melting, something else is happening. Various impacts with respect to the kind of time scales, the kind of changes in the time, changes in the rainfall pattern and many other things are a result of that.
Warm welcome to you to BMSIT at first and then to this particular program. I must definitely congratulate the Department of Mechanical Engineering for having secured this very good support from the AICT for this ATL FDP, which is definitely going to benefit each one of you who are presenting here, whether students or faculty or whoever it is. It is going to be very, very useful. In fact, we can see that the needs of the human beings have been changing drastically, right? For the last maybe 100 years or so, tremendous change in the needs that need to be satisfied. Why? Because of the kind of complexity in our life. Just now, Professor Dasat was mentioning many things we have developed to solve the problems which should not have been there at the first place at all. But anyway, we have solved them by various technologies and so on. In fact, our life has become so complex these days, very fast. And this complexity has given rise to the kind of needs to be satisfied. Look at the kind of the socio-political issues that are happening around the world. Look at the kind of swelling population that you are seeing. Look at the kind of the crunching the resources that need to be used to satisfy the people. Scarcity of resources we are seeing. Look at the military requirements, look at the government requirements, look at the societal requirements, industry requirements. Things are changing tremendously. Rather, it is changing in an exponential way. Are we really developing such kind of products, services, technologies, systems to cater to that kind of exponentially increasing needs or changing needs? Needs in terms of safety we want to reach certain places very faster, right? We want to have it very safe, we want it most economic kind of solution for a problem. We want high quality living. We want all these things. But are we able to produce that kind of technologies? Yes, we have tried to do that. We have been able to develop certain technologies to solve the problems, but at the same time we should know that the technologies that we have developed in this country, when they are trying to solve one particular problem or provide solution to one problem, they are generating 100 more.
Which is very apt as hydrogen hybrid technology for cleaner mobility revolution. This has been making a lot of inroads in terms of the media, what all it reports, whichever technical magazines we see. We recently heard Nitin Gadkari speaking about a hydrogen powered train. Also we find there are a lot of talks about aircraft being hydrogen powered. So this is something what we hear. And I being a computer science man, it's just out of interest I look into all this. Various technologies which has come this far to call something as a hydrogen powered fuel.
If you have a similar molecule like methane, instead of methane, biomass, which I gave you the structural formula as C.7H2O kind of situation, is it possible to generate hydrogen over that? And maybe we did, as I told you, the Second World War people try to use it for power generation. That is the term what I'm looking at is called air gasification, wherein you converted the solid to gas, wherein you could use it in an internal combustion engine to replace the entire fossil fuel possible. Or if it is going to be a diesel engine, you could replace it to a tune of about 80 to 90%. That was definitely possible. But if you really use certain processes with oxygen and steam, as I told you, the carbon can get converted with steam to CO and H2. I think if you can enable such a magical reactor which can do this job, you should be able to get about a kg of hydrogen for every 10 kgs of biomass what is going to be put in. And in terms of energy input, I don't know if you have noticed the previous slide, it was about 220 megajoules which you require. Here also you require something of that order in terms of fuel which goes into that one. I think this is the kind of thing. With this background, as I told you, the solid fuel can get converted to gaseous fuel. You can really look at molecules coming out of solid fuel. And if they can be utilized in a diesel engine, you can substitute completely in dual fuel operations about 70%. I'll just check if I have examples how during a certain conditions wherein when diesel was rationed in this country, how this technology came to maybe the support of farmers and other things, and try to convert into various end fuels. Maybe we started off with biomass based power generation. I don't know how many of you have visited the sugar industries wherein you use this for generating steam, and they also these days use a terminology called cogeneration. That means you generate power as well as steam for your process requirement. When you try to do that, your overall efficiencies are much higher. I think that is something which people have been looking at. Your efficiencies are going to be close to about 45-50%. That is the thought process across the globe now. Can fuel cell, that's the context with which people have been talking about fuel cells. And fuel cells, if it can have hydrogen as a fuel, you should be able to really do long distance. And Government of India and elsewhere across the globe, people have been looking at trucks, buses, railways. Can it move into hydrogen as a thing? And there are several groups also working at can hydrogen can also go into. People have been talking about various technologies internationally known. They were trying to move after the Second World War into a space wherein once you generate an unwanted material, is it possible to destroy that or try to deal with that one? I think that was a significant deviation compared to what the work at Indian Institute of Science trying to see whether we will be able to prevent any generation of unwanted materials. I think that's the basic thing which happened. Based on this, we developed technologies. I should give you some glimpse about a technology wherein we generated a technology wherein you will be able to replace diesel in a diesel engine or a gas engine completely run on gas. This is to see how societally relevant these technologies could be. In parallel, as a development was taking place, we also tried to put these technologies for use in the field. This is an example wherein an unelectrified village was being supported to see whether we will be able to provide illumination to that place. I think it was a long journey what we had, and during that period, once we started giving electricity, we said, okay, it's going to be making a big change in terms of the profile for that village. But unfortunately, I think the illumination was not something which was very I should say encouraging. They wanted beyond illumination. We started giving drinking water supply. Then we started providing irrigation. That means people in that village were able to really grow 10 times what they were growing being in a semi-arid area, and they were able to pay for services with respect to water. And if you go back to Chanakya's Arthashastra, 1/3 of the crop value can be dedicated for any land development kind of situation. Today we are talking about prepaid cards for everything, but that was the situation in about 20 years back. People used to come deposit money today for tomorrow's water. I think that was a change what we did, but unfortunately the policy mechanisms in this country and the political system did not really support such activities. It's sad that we have not been able to progress much on the rural energy scenario, but still I think it can make a big dent. Around the 90s, I don't know how many of you do remember, at least some of the senior faculty members may know, that diesel was also rationed because of the Middle East oil war actually. When it was rationed, people used to get about 5 liters of oil for every week for their water pumping application. I think this system was there in the field by that time. People who had this one, they were able to run for 20 hours, as against typically 5 hours from the diesel what they had. I think that means if you are pushed to a corner, you have a technology which can really make sure things can happen. Then in order to show the industrial level, we set up a megawatt based power generation system in the country. That is to generate electricity using coconut shell as a fuel and try to put into the grid. This was in Coimbatore, wherein it was the first generation entrepreneur who want to sell electricity to the grid and try to make sure things happen. I think this is where the technological, what I am trying to show is, if you put in the necessary process and translational component, we can also develop technologies. This is just to showcase that one. And this, again, we had several hurdles to cross in terms of taking sure that you get into the so-called commercial angle, because engines were not available. We had to work closely with many engine manufacturers. Cummins was not able to give guarantees initially. And at the end, they started giving guarantees because based on the performance which was available. And unfortunately, this could have become a big, I should say, bootstrap applications for all our rural energy. But I think the policies within this country did not enable biomass to survive as much as what it should have happened, because the solar did, because the lobby on solar was very, very strong. And this was one of those technologies wherein you have a multi-feed capability. In terms of science, probably this is one of those best technologies which could be generated. And this also enabled us to transfer technology from India to other countries like Europe. And we also transferred it to the US. GE took the technology transfer from IAC on this one. We did quite a bit with respect to power generation systems using that one. But unfortunately, as I told you, we were not able to do too much with respect to power generation because of policy enabling decisions. These are various other technology packages which were deployed. At one point of time, we had several systems across the globe, maybe in Switzerland, Thailand, Japan, US, and various other countries. To name a few, I think this is all what is being looked at. There are various applications which could have really helped in terms of dealing with this one, but unfortunately the policies did not enable. But with the decarbonizations coming in, many of these things can take a different turn together. That means if you have a technology, there is going to be a window wherein you will be able to really service that one. I'm just going to give you a very, very simple example how a cooking device which conventionally we use, that is about 5%, 5 to 8% what you see here. This is about, that means 95% or 90% of the heat is lost or energy is lost. This is the way all the emissions which come in, and people who are in the vicinity with respect to the cooking device could also be subjected to so-called emissions which can be very, very harmful. Then we developed various technology packages. This is the one which we transferred to British Petroleum from the UK. And this can give efficiencies comparable to that of a kerosene stove, very, very efficient. And this was deployed at large scale through British Petroleum in India. And I should say that at one point of time we were saving about 10 tons of LPG, wherein all centralized cooking was replaced with this technology. And the impact what many of these technologies really provided was, we were saving about 50 tons of oil every day. And roughly the private investment was to a tune of about 500 crores on this technology.
Yes, all are from mechanical background, so because of that, so everyone knows, like, the importance of softwares in our industry. So what are the softwares already used it? I think just to get a little Solid Edge, CATIA, ANSYS, ProE, Hypermesh. So basically, like, when we call about, like, mechanical engineers, or basically when you go for what, product design, then whether everything can be taken care in using a single software. So then again, like, there are lots of phases are available, and every phase we use what, one particular software. But when you want to go to when you shift to the next phase, at that time what, data need to be taken to the next level. When you're taking the data next level, it's an external platform. So there's going to be huge data loss. then again recovering back that particular thing and starting from the scratch again, it is going to take lots of what you call it. It's again basically a big headache. And verification of how much data is lost is another big challenge. So to avoid all this particular confusion, Autodesk basically started one particular project called as a Fusion. Fusion means basically, I think the meaning itself says what it is, basically a combination of multiple streams. So now ultimately they're successful in that particular part, and almost last a decade. Right now I think it has excelled into altogether a different level. Anyway, sir will give more insight on the technicalities of it, and because of the time frame, so we are making it more compact, and today we are just limiting it to only the modeling aspects of it. But later again, maybe in tomorrow day after, maybe our weekend at the end, basically, if we can get more time, then we'll be focusing more on thermal analysis and generative design. So basically, telling about this particular tool, starting from conceptual design till manufacturing, every phase can be taken care on a single platform. And it is a cloud-based platform. You need not worry about copying the data, shifting that particular thing, as well as maintaining a hi-fi machine. All those headaches are not there. It is cloud-based. Everything is available at the server end. Only thing is for what the local processing. You need a PC. Otherwise, everything is taken care at at the cloud side only. And plus, for academia, this entire software is free. You are not supposed to pay anything for this particular part. And it is not usually academic license means what? Everyone knows about this. I think we might have used academic license is what? Commercial license contains everything. And academic license contains hardly 20-30% of that features of that. But in Autodesk it's the reverse. Commercially there are multiple versions. So there is basically limited version as well as what you call intermediate version and what you call the ultimate version. So for academia, the ultimate version is available, along with what you call the cloud space. 5 GB of cloud space every person gets. As an educator, you can register it. As a student, you can register it. Anyway, Kirti Kumar has my details. If further you want to implement at your place or any other further help you want regarding the integration as well as the next level of engagement, then definitely you can take a reference from Kirti Kumar sir. Otherwise, I don't want to waste the time because it's already 12:15. Lunch break again next, and that's what actually we supposed to conduct this yesterday itself, but yesterday also again the last session extended till 4:30, and then we didn't have any further time, so because of that. So over to Vijay sir, and telling about Vijay sir, the person who pushed me into this CAD world, because I basically am a programmer, and this is a story of 1990s. And where AutoCAD was only the tool available at that time, and automation, entire thing was done by one language called as AutoLisp. And yes, I started my career as AutoLisp programmer, and then I completely entered into this segment. And the person who pushed me, he is available here. He knows, yes, because being a mechanical engineer, he knows almost all tools available in the industry. He used it. He used my multiple projects. Lot many, almost you can say 40 plus years of experience he has it, and that's what today he is there to give more light on fusion part, and today we'll be restricting more compact, we will make it compact more towards modeling part aspects, and how fast we can implement it. We'll take one engine and this thing and we'll start, and later it is the next sessions and all that we'll take care of analysis and simulations.
Fusion 360, basically it is cloud-based software, and in fact the data loss comparatively in other softwares is very less. There is no data loss, we can say. Such a powerfully it is created, such a powerfully the data can be handled here in this one. Already maybe in AutoCAD, many of them might have come to know this one. They every industry, if they want to save that data, their design information, everyone is keeping that one in the AutoCAD itself. AutoCAD drawing, even if it is done, if it is 20-30 years back also, we can access that information. Such a AutoCAD software is there. Similar way, this Fusion 360, in fact, here I would like to repeat that one. I am using the AutoCAD since almost 40 years, right from the version 1 I am in that one. Such a way, all the information at any time you can access it there. Like, if at all you go to the CATIA, or if at all you go to the Unigraphics, if the file is saved some 7 years back, 8 years back, to open it, it takes hell of time. Sometimes it may not be possible also. You may have to go for recreation of the drawing. Such a problem is there in other softwares. Whereas here, in the AutoCAD and other, even in the Inventor, even in the Fusion 360, they better still improved it. Improved the data handling of this one, they like, right? So, and moreover, as it is cloud-based, anywhere, any corner of the world, we can access it. The project can be taken there, you can use the data there. And as it is cloud-based, as already it is told, and this then CAD, CAM, CAE, and PCB design, everything can be taken care here in this one. In addition to that one, so the detailed way we can go for this Fusion 360, which is having all these features like sketching, direct modeling, surface modeling, parametric modeling, mesh modeling, freeform modeling, rendering, manufacturing. In fact, manufacturing, so many options are there. I don't want to take all those options there in that one. Electronics, in that PCB design, PCB layout, everything they like. Generative design, which is a very fantastic option they have come out in the Fusion 360. In none of the softwares like CATIA, Unigraphics, it is not there. It is not available in that one. Like such a way, generative design is there, and simulation. In fact, in the simulation like static stress, model frequency, thermal and thermal stress, buckling, non-linear stress, event simulation, shape optimization. This all comes in the simulation there, and then documentation like drawings and rendering and even animations kind of the things can be taken here in this one. So this way, all this together, it is there in the Fusion 360. Such a powerful way they have made it here. So as the time limits here, so I am going to focus only on the modeling. And maybe many of you people are having already knowledge of this CATIA and other things they like. And I'll just say, take one simple sketch here in this one, and using one sketch, how best we can make the part model in that. That's what I am going to take first then. And then I will take one IC engine and that assembly and animation of that one.
Generally, whenever we introduce new fuels, they will have some doubts whether it is whether we can work with that fuel or not, whether it is feasible or not, like that. So that this work was actually assigned by my dad took consultancy work from Mahindra and Mahindra, and since some 2 years it was nobody was ready to work on that. But after I joined as a student, he assigned me this work. But once I started, after completion, I got a satisfactory. Even my supervisor also had a very good happiness, because of we developed a new engine using hydrogen. Okay, but only thing is we experienced some good things as well as bad things. I would like to share a few things. But in my presentation, initially I'll explain the basics of hydrogen, the production, storage, including the utilization with respect to IC engine. Okay, in what way hydrogen can be used in IC engine? I'm going to explain a few technology, and if any queries are there, you can ask me at the end of the presentation. See, when I started, that time even my supervisor expressed, see, this is only for demonstration purpose, because hydrogen is not considered as a auto fuel. Okay, and also hydrogen, government of India is not given or developed any safety features with respect to hydrogen. But even today, last month when G20 was held, most of the world leaders are expressed we have to go towards the green hydrogen or hydrogen fuel, because after combustion it produces only H2. we can reduce carbon footprint. Why it is started? Already you know, since from 2015, when most of the world leaders have met and taken a decision to reduce the carbon footprint. Okay, so with respect to that only, they have introduced e-vehicles. Today, what you are seeing on road in most of them, most of the major cities, the EV vehicles are coming in, but their quoting is a zero emission vehicle. But you can think of whether it is a zero emission or emission vehicle, because if you use electricity produced from renewable energy, then we can say it's a renewable energy, zero emission. But if you use electricity which is produced from coal or thermal power plant, then we cannot say it's a zero emission, because you already know when you produce electricity at a remote place, supply to urban or cities, twice. For example, if you are consuming 1 unit, you have to produce 2 units there. So you can imagine, or you can think of how much carbon dioxide we are producing. Okay, so but maybe corporates or the government is promoting e-vehicles, but parallelly they are trying to introduce renewable energy, that is solar energy as well as wind energy for producing electricity. I think in Karnataka, Madhugiri, you know, the solar park is there. So they are developing, producing a huge electricity from there. So why we have to move towards the e-vehicle or green fuel is because of a few reasons, including the population. So you know, the population is growing day by day, and people are moving from rural to urban areas, and everybody wants comfortable life. So they are using energy. Okay, maybe in one or the other form of energy they are using, and you can observe. So the population now, 2040 it increases to 40 billion. 9 billion. So it is increasing day by day, and recently, with respect to population, we have moved to first position. Okay. So generally, even new technologies have used in America as well as European countries. Our population, that is in Asian countries, the population is very high. Nearly 75% of population is located in the Asian continent compared to other continent, and most of the energy is used in Asian continent. So with respect to that, you can observe how energy is used with respect to the industry, transportation, residential and commercial. Okay. So now we are focusing on the transportation. So even compared to 2010 to now, energy consumption is increasing day by day, because as I said, the population is moving from rural to urban, and the fossil fuel, maybe petrol or diesel consumption is increasing day by day. And parallelly, you can observe for lighting purpose or electricity or industrial purpose, the energy is also increasing. Only thing is, the nearly 70 to 75% of electricity is produced from thermal power plants, that is coal-based thermal power plant. But the remaining, maybe we have other, including renewable energy, solar or hydro, and nuclear energy, etc. Okay. So somehow we are managing, but only with respect to transportation, other than railways, we are using a fossil fuel like petrol and diesel majorly. But nowadays we are moving towards the electricity vehicles, but again produced from coal-based thermal power plants. But when we use this one, you can observe consumption, heavy-duty transportation, not only in Indian context, everywhere, including European continent or American continent. The major is transportation. So we are using diesel as a fuel. So when we use fossil fuels, the carbon dioxide is very important, because petrol or diesel is made up of hydrocarbon. When combustion happens, that is when it reacts with air, so carbon dioxide, including unburned hydrocarbon and nitrogen oxides, will be released. That is the major issues with respect to fossil fuel. Actually, I prepared for 2.5 years. I'll skip few slides. Okay. These are all the data available in the. So same thing. heavy duty transportation, including Asian specific, we can observe it is increasing year-wise, and even North America and Europe and other countries. So in Asian specific, including India and China, the maximum transportation or the fossil fuels we are using. So this is with respect to the sector-wise, okay, conventional fuel or diesel, natural gas, like this. So you can observe the conventional fossil fuels, including petrol and diesel, is used major here, and including natural gas. But nowadays we are looking towards electrical plug-in or hybrid vehicle, including ICE engine plus battery operated vehicles are there. Nowadays is available.
Hydrogen produced through green route has a lot of applications where you are not using any fossil fuel burning for hydrogen generation. And also, recently this Indian government has come up with the National Green Hydrogen Mission, wherein around 20,000 crores have been earmarked for research on moving hydrogen, right? So I will just try to talk about my area, like how we can use hydrogen in diesel and petrol engines. Although some of them are old techniques, I will just skip them through, and then I'll try to go to some latest work what are happening. If you typically see the carburation technique is an old technique, you can just straight away take a new petrol engine, and then instead of petrol straight away you can send in gas here. As you can see here, compressed hydrogen gas here, and then here. You very well know that stoichiometric CLA ratio for hydrogen and air is around 30:1, where one part of hydrogen when combined with 30 parts of air, because its calorific value is very high, and then it is during suction you can just draw in like petrol. Like petrol and air are mixed with the 14.5 stoichiometric ratio. Likewise, we can use this combination and then run the engine. I'm not talking about all this, I'm just focusing more on manifold induction and rest on. This is just a diagram illustration. As you can see here, manifold induction means engine has a suction stroke where pressure drops below atmosphere. You can straight away draw this hydrogen mixed with air, and then it can be used in the engine. So I'm just showing you some of the gas supply arrangement, because as you know, hydrogen is a very if it catches fire, we will not come to know about that, and it is a very not so safe fuel. We need a lot of safety arrangement before it can be used. Hydrogen drawn from say around 160 bar, it is reduced to 1 bar here. There are 2 pressure regulators, and one pressure hydrogen enters you need to know how much hydrogen is going here, and then it will dip in a water, so that when flame happens, it again reversal flame will not reach your cylinder. There are wet trap, there are dry trap, and then there is a another flow meter where we can measure it, right? So here we also have a hydrogen leak detector, where if there is a leak in an engine, you can straight away see here. See, I'm showing hydrogen induction with one engine, and whereas hydrogen injection I'm showing with another engine, simply because you are aware of that this is a simple conventional mechanical fuel injection system, wherein if you typically see the engine, it is TV1 engine developing around 5.2 kilowatt, and then with this much compression ratio. So what is that I'm trying to say here is, if you can make use of such a engine, you have to make certain arrangements where hydrogen has to be pushed inside the engine. See, before I go to the experimental readings, I would like to also talk about how we can analyze hydrogen mixing with air. This is a simple venture wherein you can see air is coming here, and then hydrogen. You should have all these metal pipelines, so that rubbery items can embrittle because of the hydrogen. So you can make a good mesh of this air gas mixing. So I'll just skip through, and I'm just showing you couple of slides where we have used hydrogen ranging from somewhere between 0.0252 as low, as low as 0.2 kg per hour. If you typically see the CNG and then LPG, the flow rate can go up to 1 kg per hour, whereas the hydrogen is hardly, it is even 0.15, 0.2, the engine starts knocking because of the very high calorific value. So I'll quickly go through this because here I want to show you how this, when we increase the flow rate of a hydrogen, how this CFD will show us the mixing here. So it is increased to around 0.05 kg per hour. You can see here the gas entering, so air is coming this side, and also we can see the velocity contour, and it is increased to 0.075, and then 0.1, 0.125. You can see more gas is entering here. So there is no control here. Control, in the sense hydrogen flow rate is not controlled because it is continuously flowing because of the engine suction here, right? So similar conditions are maintained here, and it is now 0.15, and then we have stopped it at 0.2 kg per hour because I said in the induction method there is no control over flow rate here. Continuously the gas is flowing, right? So if you see what is the effect of this such a work, if you are interested in working on a hydrogen inducted engine, so what is that we should look at? See, these are the parameters. Anyone who is working on hydrogen need to look at these parameters. So one should look at how the flow rate will affect your performance. And you are all are aware that injection timing, this is with respect to the liquid fuel. The top one is gas flow rate, injection timing, injection pressure. This is a venture. You can see here venture, different ventures with different diameters can be used for air and hydrogen mixing. And then combustion chamber also plays a very important role. And engine types, as I said, the engine which we have used in this arrangement is a conventional mechanical fuel injection system because you already, all of you know, these have a limitation on the injection pressures of the order of 300 bar. If you are trying to go beyond 300, one should go for common rail direct injection injectors where pressures of the order of 2500 bar can be achieved. So I am showing you a old work wherein what is that we have done is here. We have done, I am showing only two parameters here. One is flow rate, another one is timing. And maybe you can also work on with the different pressures. If we suppose say that dual fuel means what? The engine is not running completely on hydrogen. It is ignited with diesel or a biodiesel injection. As you know, if hydrogen is compressed 30 times also it will not.
I don't want to trouble you or make you more and more about hydrogen. We just wanted to tell you what our company is doing for that. That's it. What our company is doing for hydrogen. If at all it is considered as a fuel. Of course it is a future fuel, but what we are doing. So before that, let me take you through some slides about our company particularly, what exactly we are doing. Many people are aware or may not be aware. Of course, here everybody is aware what is our company, but for others, I will just give some brief introduction about our company, what exactly it is Tenneco, or sir already told it was Escorts, it was Federal Mughal, and now we are Apollo actually. Tenneco is moving to Apollo. Apollo is a buyer actually, is an investor, buyer, etc. Then I will try to talk about what we are producing as a general information to everyone. Then I will talk about alternate fuels, what exactly. This I think more or less everybody is aware with respect to the schedule what I have seen. And here are the things where exactly. I think this portion not to be recorded particularly when I say to stop not to record because lot of trials are ongoing, lot of engine tests are ongoing. The result which you see is may not be matured also, and that cannot be taken as a final one. I will just to give a direction that which direction we are moving based on our experience and testing. Okay? Right. So Tenneco. as a business group, you might have seen various names here, Gatsay, Champion, Deva. These are not so familiar. Glyco may be familiar. But what I am trying to say that our company manufactures the product from two-wheeler component to marine particularly. So this is the wide range what we are having. That means small engines, light vehicle like cars, commercial like passenger commercial, transport, logistics related, off-highway, that means JCB type of vehicle, industrial segment, generators, marine and railways. These are the areas. In India, of course, we are not in marine, rest all we are into in India particularly. So, we are around 71,000 team totally, globally. And we have 38 technical centers. One is in Bangalore, where I am managing. 132 manufacturing sites worldwide. Of course, we have our own dealer segment, aftermarket distribution center. That means our products are not available in SJP road or anywhere. We have our own network of dealers where they buy, authorized dealers from the company itself. For example, Tata Motors says, these are my authorized dealer and we can sell it to them. If I sell it in an open market, my product which is being selling to Tata Motors, I will be penalized and I will be blacklisted. So that's the penalty or the seriousness. So we supply aftermarket only after the 5 years of product launch. Say for example, today Thar vehicle or SUV 700 which is moving on the road, these parts will not be available in the market, for example. Of course, it is available with the main dealers. But it will come to the regular open market maybe after 5 or 6 years, because that's how the proprietary item starts. Of course, this is a network what we have, not to take much time. And here our technical centers where we are integrated, working together wherever, for example, Bangalore, India is one of the technical center. I mean, it is difficult to get recognized starting from a private company in India, just a private company, Escorts, making some two-wheeler and tractors parts, is recognized when it is moved to a Tenneco like a global player. Recognized within them as a technical center itself is an achievement. Efforts and credit goes to our predecessors, my bosses, who have done a lot of work. Maybe this is the business segment, how we are categorized. So not everyone, 71,000 people working on. I am categorized under powertrain, means engine to wheel. Engine components, transmission, gearbox, clutch, brake, and final wheel. So this is what is called as powertrain, where we are getting. Clean air is nothing but the name itself says clean exhaust. That means there is a group which manufactures only the silencers. Terminology is silencer, regular terminology. We call it as the exhaust complete package. That names are changing with respect to the vehicle. And here some springs, chassis springs, etc., shock absorbers we make. And this is purely our aftermarket caretaker, particularly. This is how we focus. Center is the particularly what I can say is market drivers. What market? Market in the sense, the engines in the market, what they expect. Less friction, advanced combustion, electrification or hybridization, where fuel economy goes. Emission, how you manage the heat and leakage. That's how the emission goes. Durability, because all our components are mating components, rub with each other, friction will generate, but finally we need to have a lifetime solution. So how you address fatigue as well as wear. Then how you address finally the seal. I mean, both are same, but here the coolant and other things will also include. But surrounded by our own product, like this I will come to later, piston, which we are very, very familiar, spark plug, liner and gaskets, rings, bearings and bushes, valves, and some advanced pistons also. Like since you are not that much familiar with what is petrol piston, what is diesel piston, only you might have seen the bowl change in diesel versus gasoline. But there are some advanced changes. We call it as the advanced gasoline piston that is used in the BS6 vehicles now.
Sir is Mr. Nandish. He is CEO and founder of ITARC Innovation. He helped us in, actually we started actually, we are not completely full-fledged with hydrogen. We requested him to provide the kit, hydrogen kit. He has given the kit, and the same kit we have worked in the laboratory. So he wanted to show the demonstration how the hydrogen powerful is, how it is going to work. With that, we request Nandish sir to give some small sampling from the college.
It's been a glad to connect with all of the hydrogen expertise with alternative fuel also. Myself Nandish, and I'm founder of ITARC Innovation. We basically work on two product development in the field of automotive. We work on vehicle dynamics, safety, crash and the plastics. This is the first step for us to starting with production of hydrogen, oxy-hydrogen. We are in level 1 of our experimentation. Currently it's been like 20 hours we are just hearing to the lectures of hydrogen, but we do not see what exactly hydrogen, how it is visible, how it is produced. As we know, the petrol is abundant, means it's available currently, and we are using this fuel to run our cars and bikes. As pollution is increasing day by day, it's our responsibility to convert from commercial IC engines to the electric or hydrogen combustion engines. Currently the works are going on with hydrogen combustion engines. By next 2 to 3 years, BMW and Mercedes are coming with their own hydrogen combustion engines, and they have been tested in Europe and Middle East already. And due to infrastructure lagging in India, it's will like 5-6 years to come to India, but EVs are ruling the world. But the future is hydrogen. And as we start, we are working for on the product development of kits for AOTS. AOTS is nothing but advanced hydrogen on demand, but we produce hydrogen on time. We are not storing it using any storage hydrogen tanks, because it will be bulkier and the mass of the car will also increase and the efficiency will be very less. Our kits basically produce hydrogen depending upon the CC. We are working with the petrol and diesel engines. We have a bike starting from 100 cc, the cars from 1.5 liter, 1500 cc, 2000 cc, and the trucks which comes to 9000 cc as a bigger engine. And we can install this kit for the generators too, because to reduce the carbon emissions, because BS6 has been one of the best advanced in their exhaust systems, where we have a very less amount of carbon monoxide or nitrous oxides coming out of the exhaust emission. But BS3, BS4 vehicles, they need to have an improvement in their exhaust circulation chamber to reduce the carbon emission. These kits will be a supplementary to convert our cars or an add-on kit, so that we can reduce up to 30 to 40% of carbon emission using our kits. And this basically works as a basic electrolysis process, where we are using pure distilled water, and we have anode and cathode. We are using a SS plate of material, SS316 is a plate, which we have a collab with 4 plates. This kit is used for only for 100 cc, where it produces only 5 to 7 LPM, liters per minute in a gaseous state. And this exhaust, where the hydrogen gas produced, we will insert to the air intake chamber next to mass airflow sensor. The produced hydrogen gas along with the diesel or a petrol go to our injection chamber. First it decarbonizes the entire pistons and valve. After decarbonizing, it acts like an additive fuel, where 15% as an add-on for current existing running vehicles with a petrol or diesel, where we will have a performance increase in 20% and pollution up to 40% reduction, and efficiency increasing up to 20 to 25% according to the driver, how he drives the cars. It runs basically in a lean mixture, not in a rich mixture, where lean mixture will have a better efficiency in the car and the durability will also very good. As I show right now, this is one of the low cost way where we can produce hydrogen. Yesterday, sirs and all expert in IISc and in couple of research institute in IIT Delhi and IOCL. We have a bigger missions with large amount of investors has been invested. I am just showing how hydrogen gas is produced in a simple way. Now the electrolysis process is going on in this kit, and I just keep this to this water. You can see the bubbles here. This is a hydrogen. Anyone, if you're interested, you can just come, and you could not feel any pressure or odor. It is odorless, smellless, and we can't see visible because that's the specialty of hydrogen, which cannot be seen by naked eyes. So that we'll have some short experimentation so that how it is more effective, means it's very harmful. Like a couple of professors asked the speakers to get the hydrogen setup labs in their college. Setting a hydrogen workstation in our college, the financially and the investments are very huge. And the main thing, this is very harmful, like setting a gas station inside a college. Any misfire, combustion, entire, Handberg reaction, how entire, like 150 people were busted in 1930s, 40s, accident take place. Now I will just show the experimentation. Just give me 2 minutes. Let the hydrogen gas fuel up in this glass, so that if you, due to this soap powder what we have used, it will not emit the hydrogen gas to go easily interact with the external climate. Give me 2 minutes, sir. Let it hydrogen gas fuel up in this one. I will show the reaction. If you want, you can see the reactions what is taking place. Inside the beaker, I have used a soap powder. That's all. Yeah. Yeah. Water. Show like how explosive is the hydrogen gas. Yeah.
No, you are storing the hydrogen inside that.
Yes, sir. Yeah. Because hydrogen storage is one of the complication process. We need a bigger tanks with better carbon reinforcement at the upper case.
Its volume?
Sir?
What will be the volume?
Now I am getting at 5 LPM, sir. Yeah.
So it's stored in the bubbles?
Yeah, it's stored in the bubbles.
The kit is proven, we can use it in the car?
Yeah, yes sir, we have ICAT certification for this kit. Currently for 2-wheelers it has been certified. For 4-wheelers, the car which is outside, we are testing at different regions at altitude because to reduce the knocking in the car. We have successfully completed 30,000 kilometers, but we have got means we have reduction in the carbon and monoxide and sulfuric acid which has been emitting from the car. And we have IOCL certification. For the approval of that car, what we have did experimentation for that. Yes, sir.
That means we can fit it in our
2-wheeler, yeah, currently existing.
No bus.
Sir, this will be on external, will mounting at the outside, so that it will not be directly injected to the air intake near the spark plug. It will be given to the air duct, means in the air filter hose. The petrol plus this hydrogen gas will mutually go into the air intake chamber, so that the thermal efficiency will go, because 2 fuels are going at a time, hydrogen and petrol. Where first this hydrogen has a capability doing the decarbonization. You could have seen in YouTube nowadays they do decarbonization of the car. Decarbonization is nothing but they are using this hydrogen to decarbonize our valves, pistons and inside engine chamber. But we are giving the very limited amount for the particular devices in the cars according to their CCs. Yeah.
Sir, what exactly do you mean by decarbonize the fuel out there?
See, I will show here what has been done, what is decarbonization basically.
Did not come out? No, that's why use the soap powder. Maybe having some limited capacity. It goes beyond.
No, like I'm just sparking it out.
Madam,
no, like
chemistry, madam.
No, we need small experiment.
No, flame ಮೇಲೆ ಬರುತ್ತೆ ಅದು ಕಾಣಬೇಕು.
Means hydrogen gas already exhausted, sir, because when the time I came from here, that's what. Okay. Instantly we should have to keep and the combustion lights were, because already covered the external climate, sir.
Your hand is shaking.
Yeah, you asked regarding the decarbonization. Yes, sir. This distance has been worked with this hydrogen gas which has been injected for the two-wheeler, where we have used, this has been seized because the metallurgy of the current existing IC engines are developed for petrols and diesels. We are using two more gases where we'll have a more temperature generated inside the engine chamber. Due to that, this material can't withstand. IC engines are developed for the standards of petrol or diesel, which have developed with aluminum and cast iron and engine cases. And due to the excess amount of hydrogen deposited on this piston and the fuel what we have supplied, and due to this there is a piston jam, means it has been wear out the engine case bearings and the pin. And decarbonization takes place once you give the hydrogen gas generated to this, the upper layer of the piston. It acts like a soap where we clean the dirt area. That's the specialty of hydrogen. And this is a connecting rod, and this is aluminum cased.
So it is basically removing the carbon.
Removing the carbon, basically. That's a decarbonization. What is taking place?
Like that. From the
carbon deposit.
rings and the walls.
You can see this walls till what amount that is being wear out.
Thing will be set keep there. In the this one also.
We have, you can see you can see the level of the bottom. Yes, sir. No, it's just plate. 316 and 316 and 304. 304. Okay, sure, sir. Yeah. You can just. Yeah, it's very dangerous. It's more dangerous than petrol and the gas. The entire area will be collapsed because storing a large amount of like 15 to 20 kg of hydrogen gas in the cylinder, a minute amount of spark is enough to blast the entire area of like 500 to 1000 square feet.
Store less quantity of hydrogen.
Yes.
I think anything happened?
Nothing.
The last time what we did, Andra, before doing this experiment, I asked so many questions.
The difference once I on the car is running with the hydrogen and without running with the hydrogen. How the exhaust gas are emitting. We can smell like
Start out with
One more plus.
Thought like this kit is producing only hydrogen, but it is producing oxy-hydrogen in the ratio of 2:1. And you know there are so many gases like brown hydrogen, green hydrogen, yellow hydrogen. And this is wet electrolysis process. There is dry electrolysis process and wet electrolysis process, and we are using wet electrolysis process to produce the hydrogen gas. And I showed you the engine blocks and the pistons and the cylinder liners at the downstairs. When we are manufacturing the current engine when we are converting current IC engines which run on petrol to the hydrogen, we want to enhance the metallurgy. So these are the currently what IC engines are running with this type of material like aluminum, cast iron, stainless steel and iron based polymers, and IC engines are come up with the cylinder liners made up of nickel and steel coated in their cylinder column. Once we are going for hydrogen combustion engine, the entire components what we are using has to be upgraded with the finer material with more R&D has to be done on the metallurgy. You can just read out the things, and if you want you can have a snap of this one.
With the conventional vehicles, we are all used to the hydrogen fuel cell electric vehicle. Normally we mean automotive vehicle to start with, although we can say there could be other applications also, but here at least we'll start with automotive applications, maybe in terms of trucks, bus, cars and that kind of thing. And in that sense, this talk can be looked at as compared to a conventional automotive vehicle, NVH aspects of it, what would be the change when we say either fuel cell or electric system is there instead of the internal combustion engine, what would be the different aspects that will get highlighted. And also the other perspective would be some bit of introduction into the NVH and acoustics itself. When we say NVH, when we say acoustics, what do we actually mean? And design is a very wide terminology and topic. Lot of aspects would be there in terms of, you can say, starting with concept design, then you can say concept evaluation, concept selection, and so my focus would be partly a bit more focused on the simulation part of it. That means assuming we have a design, how do we check that it works okay, or how do we rate a design and that kind of things. Although there is much more to design. When we say NVH design, there is a lot of perspective, and one can even say design can exist independent of simulation. Simulation is not mandatory. Designs have been existing well before any simulation started. Simulation will make it more efficient and more faster kind of a thing. So simulation is one window into overall scheme, although that will be the predominant focus here. And then there are also several aspects of the manufacturing aspects. How do you actually for example, the sound absorbing materials, how do you actually manufacture it, what kind of materials are there any biohazards associated with handling of this material. So many aspects would be there when we say design. This will be one subset of it, that is one context. And I will try to generalize it from what we may normally be exposed with respect to a general finite element analysis or a structural analysis simulation. In mechanical engineering, as we know, finite element analysis and simulation is used in a very wide way. Almost for everything, anything and everything, simulation is being used. Finite element analysis itself can be thought of as one aspect of simulation. There are so many other kinds of simulations also, we can say, even as applicable to NVH. We can say like some analytical equation, we can say numerical equations we can solve, or some control systems we can solve. So many perspectives are there. So in that sense, again, bit more related to the finite element simulation. One advantage being that it is general purpose in nature. That's the main advantage. So once it is general purpose, you can use it for any application, conventional application, new application, although the focus will be on certain specific things applicable for that specific application. So these are some general comments with respect to this. I have a wide number of slides. Then I also have some simulation software on my computer. Depending on how it progresses and maybe what questions you ask and your interest, I will see whether we stick to case studies or I give some general concept or maybe some small demo I will show. We will see how it progresses. And feel free to ask any questions. I will also prompt in between every maybe 10 minutes. And in between, otherwise also please feel to ask any question. My thinking is that maybe at the end of this talk, at least some perspective of when we say NVH of a vehicle, in that sense NVH of a fuel cell electrical is a bit too narrow to be able to say that. It is, the broad aspect is NVH of a vehicle, and then what are some specifics of a fuel cell or electric vehicle will come into that. And also how do we get started with it? Suppose I want to do something, I want to improve the design, I want to change something. How do we actually look at evaluating any design, or I have two design alternatives, which is a better one, how do we evaluate it? And so these kind of ideas if you can get. And we also, our company as well as a lot of other simulation companies, one, they sell these softwares to the commercial industry. These softwares, what we'll be seeing, are the ones which are used in the actual industry. Globally, Indian companies, all. Nowadays, the level of the simulations have reached such that in India, whatever is global is happening in India, and whatever is India is happening global. So there is no necessity that, for doing some advanced thing, I will go to US or Germany or that kind of thing. You can go, but the same thing is happening here. We can, if you want to, if it is a really technical perspective, we not go. Otherwise, we can look at going. It is really like that. All the global companies are doing their own work here, and although some bit of security, confidentiality there, but it is happening here. So our engineers are doing this work here, and Indians are going outside and doing the work. So it is global. It is truly global, at least as far as the simulation technology is concerned, because all we need is a simulation capability to start with. If it's a manufacturing plant, then you have to set up, and much more things are needed. So these tools, some of what I will show are the tools which are being used globally across for these applications, even in India also. There are many such tools. It is a competitive environment. There is no just one tool. Like this, there will be maybe 2, 3. Some tool has some advantage, some tool is slightly better at some applications. It's more in a degree of specialization or efficiency, it will vary. Most of the tools will have the fundamental capabilities. If there is no fundamental capability, the tool will not exist in the market. Market forces are such that for some, if it is giving some wrong answer, means more or less in 1 or 2 years it will survive. Otherwise, nobody will buy that. It will die at death. That is like that in the simulation industry nowadays. So with that, let's just start with some of these slides. So these are otherwise our standard slides which we use in our company to interact with auto companies or the suppliers and so on, to try to showcase the use of these technologies for those applications. So when we say automotive CAE, again it could be automotive here in the context of any four-wheeler basically. And what are all the different automotive CAE with respect to NVH? We can call acoustic, we can again NVH itself we can say broadly. At a working level, we can say vibration simulation is one perspective of NVH. There is some vibration happening. I have to estimate or calculate what is that vibration. And what is the vibration means? We usually mean acceleration level. Put an accelerometer, you will get an acceleration versus frequency. That is the vibration at one point. How do I simulate that? Would be one perspective. Other perspective would be the acoustic perspective. How much noise is getting generated? We need a microphone to measure a noise. There is some equipment. I hold a microphone, or I'm standing next to it. I hear some noise. How do I quantify that and how do I compute that would be? So broadly, the acoustic part of it. These are two, so noise, vibration, we talk of harshness is other term. Harshness is one perspective, is that of a feeling. How, maybe you feel a vibration, how rough it is or how smooth it is kind of thing. It's a bit more abstract in that you can say. At a practical level, we are dealing.
What is the fuel cell? The fuel cell, we know that the hydrogen is the fuel what I am using, and oxygen is the accelerant. Okay, you will be having two electrodes in the inside the fuel cell, and we are passing hydrogen as a fuel and oxygen or air. You can pass this electrode, and whatever the electrolyte which is going to be responsible for generate the electricity, and finally we are going to store it in the cell. That is what, and this complete mechanism happens in the fuel cell. This is what, and exhaust. After complete process, the exhaust, or what you say that waste, you are going to say, instead of in the internal combustion engines, you can notice that you are going to get a smoke or methanol, okay, it is dangerous to drink. But here we are going to get the exhaust as a pure water and the heat as a exhaust. This is what the fuel cell defines, okay. As per the definition, you can say a fuel cell combines the fuel and accelerant electrochemically to produce electricity. That's what, okay. So what my talk is going to relate, I am going to connect after 10 minutes, okay. This is the structure of internal one fuel cell, okay, one single fuel cell if you take, okay. And we are going to call this as a PEM fuel cell. And I told you, right, depending on which electrolyte you are using, on that basis we are going to call that as a PEM fuel cell, or this is what low temperature fuel cell we used to call, okay. And high temperature, nothing but we are going to use other than this polymer electrolyte membrane or solid membrane, we can use other phosphoric acid as the electrolyte, okay, which is responsible for generating this electricity. or you can say electrons flow, okay? And platinum as a catalyst, and you can use nickel catalyst also you can use, and carbon instead of carbon black, you can use other electrode as methane, okay? So like that, you can use a different electrodes to generate this, okay? That is what we discuss. You people discussed already this chemical based reaction setup, okay? So then it is going to generate the anion and the cation. So in the cation, you know that anion, you generated this electron that is going to be stored, and your exhaust, it is going to after process, you are going to get pure water. Okay, this is how the process works. Okay, you study in detail in the 4 days, but just I am reviewing this and refreshing the things. Okay, and this is the layer wise stack. Okay, this is a 10 fuel cells we arranged on a stack like this. Okay, and we are going to pass this hydrogen as a fuel and oxidant as a something oxygen or air. Okay, so in between we are going to fill the electrolyte. This is how it works, the fuel cell, and this is a little higher version. Okay, 3 kilowatt it is going to generate and 48 volt delivery of the electricity. Okay, and automotive fuel cells, PEM based fuel cells. This is a car which is really the hydrogen car, okay, which is using the fuel cell based. Actually, it is not a combustion, fuel cell based, and we are going to place complete hydrogen fuel in this, and that is going to be passed to the fuel cell. Then it will be stored in this act as a battery itself. Okay, so now I am going to end here at the battery. Through the battery, I am going to control the motors. Okay, the torque, how it is going to generate, and what is the responsibility of ECU to conduct or run the motors. Okay, and we are going to discuss in the further topics. Okay, so these are the vehicles, even lightweight vehicles, hatchbacks, okay, even buses. Okay, we are using in so many places this hydrogen as a fuel and fuel cells. Okay, Mercedes-Benz, this is an example you can notice here. Okay, and in the European fuel cell bus project, you can see this. Okay, the high pressure hydrogen tanks, and here the fuel cells we are placing. It is going to generate the power and store it as a battery, and through the battery we are going to control everything, even the torque. Okay, and we are going to control almost all the infotainment, even fuel level control, monitoring, and charges control. Everything we are going to control through this fuel cell only. And this is a very small fuel cell what they generated. Okay, this is used for actually laptop batteries. Okay, instead of using lithium batteries, we can use this fuel cell based batteries. You can see here there is a little hydrogen we are placing here, and that is going to be electrolyted, and it is going to generate the power, or I can say electricity. Okay, that is going to be used for this, and you can use it for hardly 1 year you can use with this power. That is enough, because you are going to consume very less power to conduct laptops and all. Okay, and this is a larger level, that is a stationary power. Okay, stationary power, like how you are going to use generators, all those things. Okay, so you can see here this is a bigger generator for any factories or any corporations to run home appliances. So you can use these batteries. Okay, the fuel cell batteries. And what is the pros and cons? The people, why till today people not implemented as reality? Why not in India? Okay, India, the problem here is we have some generating a hydrogen fuel itself a challenge. That is what the main concern. Okay, but here the advantages is take higher efficiency compared to the IC engines, combustion engines. And the second one is a very important factor we are going to consider in the eco-friendly kind of issues. Okay, so the zero emission. This is a very important zero emission, because the exhaust what you are getting, that is a water. Okay, there is a pure water we are going to get, and no moving parts in the stack, so there is no any emission. Okay, but the thing is here initially the cost will be very high, because the materials and labor, economy of scale and conversion of or you can say the producing hydrogen is a challenging job. Okay, so the durability, the membrane what I told, right, the PEM membrane or solid membranes. Okay, the durability is very less, depend on the process. Okay, continuously it is keep on electrolyting. Okay, it is going to be damage very fast. Okay, that's what the problem is in the membranes, and even catalyst if you use I told, right, the nickel catalyst, all those things. Okay, which is very difficult to maintain. Okay, there is a problem, and the lack of hydrogen infrastructure, and even till today the people are okay, in India especially, producing the hydrogen, the pure hydrogen, it is very difficult. Okay, and there are a lot of challenges are there. The people talks about like how they are generating the fuel, okay, through this hydrogen, that is very challenging, because the pure hydrogen generation, again they are using the fossil fuels, that is the discussion point, okay. So but anyway, the hydrogen fuel, it is going to be very eco-friendly and cleaner environment we can make it, okay, the mobility point of view. And here you can see that larger air buses, all these things, okay, they are using the hydrogen and filling the hydrogen tanks, okay, not to the fuel cell, they are going to fill to the tank, okay, through the tank it will pass it to the fuel cells, okay, and these are the producers of hydrogen. And Ballard is the one which is larger manufacturer of this fuel cell based thing. How do fuel cell car works actually? Okay, so it's very simple. Like we are filling the hydrogen in this tanks, 2 tanks. Okay, and we are going to pressure the regulators. Through that, we are supplying to the fuel cell. Fuel cell is not a one single cell; it is a stack of hundreds or thousands of fuel cell will arrange, and finally we are going to collect this in terms of a battery. Okay, the whatever electricity produced, that is going to be collected in the battery. Okay, through the battery we are going to control this torque of the motor, okay, and brake control system, everything controlled through this battery. Okay, this is a schematic direct hydrogen pressure. Okay, so here the tank is there, we are going to pass it through the anode, and we are going to pass accident here. Okay, accidents in the sense air or oxygen generally, okay, that is going to make a thing. Then sometimes temperature rises, it is a coolant will be applied, and ultimately this is hydrogen pressurized FCS fuel cell. This is how the power will be drained. Okay, power is going to pass through this and finally reach to the motors or wheels, I can say. And this is within the components. Okay, energy parameters, how it passes.
So they have given a very detailed study about hydrogen fuel as an internal combustion engine fuel, not as a fuel cell. And then some of those important things which I have summarized, and I am going to have a PPT presentation here. We all know that, so under proposed Green Deal program, especially not only in Europe, in every part of the world, so when India also is going to be in that program. But as per the articles, they are studying under European Union, so they have mentioned that, so the net zero, or to say that completely zero emission or greenhouse gas emission, so to be achieved by 2050, that is what they started as an introduction for their review. And so the interim target of this only like a 55% relative to the, so 1990 refer to the years by 2030. So far they say that 20% of that achievement has done. So what they are supposed to do 100%, but only 20% has done so far by 2020 according to them. That means there is a significant work still need to be done in that area. So to make sure to reach to the 100. So in that expectation, so definitely in the mobility sector or automobile sector, they feel that alternative fuels are the one which have been most in the research. Actually, when it comes to the what is that alternative fuels, expectation from the alternative fuel is something like technically feasible and economically viable. So we can say that many alternative fuels can be found, but if they are not technically coming into picture, that means they are not operating properly, or it is good operating properly, but for that we have to spend huge investment for an engine or operating costs, so that will also not become any proper solution. So right now that is a challenge. And so they also of course reduce the CO2 emissions or any kind of greenhouse emissions, that is for the largest extent. So the one thing is they should be feasible, another thing is they should be intended work to be done, which is a emission control. So current alternative fuels which are all in the discussion, so definitely we know that ethanol, methanol, biofuel, propane, natural gas, these are all already what we can say some or other way we are making use in our internal combustion engines. And hydrogen is also considered as one of things which is quite challenging. That is where this workshop or this what FDP has been since beginning we are discussing. So they have compared so for a zero emission technologies, what are the things at present we have been looking into? So definitely the electric vehicles, we find it is the only savior for us, but definitely not, because it cannot come into the what to say long range kind of things, or to say heavy vehicles and all. We can't able to really get into that electrical vehicles or electrification of automotive sector. So the fuel cell technology is other one, and then hydrogen is the one which is for a IC engine. So these three are considered to be the three prominent technologies which are promising. So they try to compare in this review paper under various parameters. So comes to the production, infrastructure and operating costs. Right now we can have a complete picture about the battery vehicles, but fuel cell and hydrogen still not on the road. We cannot say anything. But so in that we can see there are three types of arrow marks are there. One, the downside, which is red color. One, horizontal, that means right side, moving right side, which is a yellow color, so orange color we can say. Another one is a green going upward. So these three indicates that, so green up is a good, and then so horizontal yellow color is a average, and then red down is a not really good. This is kind of indication they used in this paper. It's very beautiful indication they have done. So when it comes to the production, infrastructure, operation and cost, battery vehicles are really expensive, that we know, compared to IC engine vehicles. And so come to the battery life, if it battery goes, then maintenance will be, again it is another big challenge. So when it happened to that, so it is not really good in that concept of production and infrastructure. That is what their opinion. And the other two we haven't tested, we can't put anything. And come to the sustainability for daily usage, it's average. So for a daily usage, maybe within the city, within the short range electrical vehicles can, but long range cannot. That is why they are not giving the green or upward. So it is an average. But comes to the fuel cell vehicles, we haven't produced, we haven't running, or not extensively on the vehicles is tested. So they haven't commented anything on that. So come to the hydrogen vehicles, they are feeling that, so there are substantial, what to say, researchers have told. So it is a sustainability for daily usage. That means heavy vehicles can be used, light vehicles can be used. So except maybe motorcycles and all due to the storage kind of thing. Other than that, so that is giving a very good thumbs up for that. Come to the driving range. Driving range is we know already. So electric vehicles not really good. Fuel cells and then hydrogen both are really good. So they given a green and upward for that. And refueling time, definitely. So refueling will be take a lot of time. So even if you say fast chargers, so will take at least half an hour to an hour for a 30 to 40%. So you can't get 100% charge for any battery within a short period. But refueling is easy for hydrogen or even for a, means hydrogen is used in the fuel cell. That is why they say refueling is very easy. Come to the fuel efficiency. Fuel efficiency wise, battery electric vehicles really good. Fuel cell vehicles good. Why? They run by electric motor. So when we use electric motor, the efficiency definitely goes to the very high. But when it comes to internal combustion engine, due to certain, as we said that in the first or second session, the thermodynamics second law, we can't violate that. We have to go with that. So any of the heat engines. So in that prospect, if you see, it's an average. So that's what they said. And comes to the durability. So fuel cell. So we know that degradation of fuel cell inside catalysts or whatever things are very sensitive. So in that sense, they have given a red mark for that. It means it's not really good. Come to the batteries. Again, batteries are not really that much of a very long life one or durable one. So in that sense, they have given. Other than battery, I think in an electric vehicle, most other parts are reliable. If you talk about electric motor has been for a long time. So it has been having a very durable thing. But comes to the battery only, if I'm not mistaken, so they are not having a very good durability. Comes to the hydrogen engine technology. IC engines are very durable, that we know 100 years we have been using the IC engines. It has been in the mature stage. Only we are changing the fuel, so they have proven for the durability. Come to the climate change, climate protection. So in that sense, like a hydrogen fuel is good because it doesn't have carbon, definitely zero emission. If you happen to produce the hydrogen in a green way, the green hydrogen can produce a so zero emission. But when it comes to battery, they didn't put high. The reason is battery disposal is going to be the another climate problem. So that is why they put it as an average. So this is a very beautiful comparison they have done between the sustainable technologies of today. And properties, this is also very beautiful what I find in this article. So they have given a wide range of properties which are required. See, I have been I'm automobile engineer, so 20 years plus I have been into the teaching and also research. So lot of properties I know, but when I see here in the research, so there are few other properties they are taking into consideration. So which seems to be like a really new learning for me. So even after having so much of years working in the automobile field.
To create or develop a new engine, a new hydrogen engine, better we need to change some parameters, processing parameters, or you can say here, if you look into this, here majorly concentrating on injection, okay, direct injection as well as suction and as well as compression ratio. Those they are going to change the parameters and find the efficiency of 50-53%. So for our thermal efficiency over here. So if you look into this, okay, I don't want to discuss much on this, but I plan to discuss more on the articles, why we need to select these articles, what are the parameters we need to consider over here. So just briefing out. So if you look into this, beginning almost from 15 years, people are looking at impact factor, but however, impact factor is overruled. Okay, nowadays people are not looking to impact factor because citation factor, impact factor, and as well as scopus, and as well as if you look into indexing, lot of things are coming to picture. That is why to combining all these parameters, people are looking to they call Q, okay, Q1, Q2, Q3, like that, Q4. So combining all these parameters, they are going to say within 25 range. Okay, if the ranking of any journal within 25%, they are going to say Q1 and 25 to 50, that is Q2. Like that, they are going to use a hypothesis. These are the parameters people are selecting. Okay, to analyze Q1, Q2, Q3 like that. So just I'm skipping this particular slide. So looking into next one, why before selecting any paper, we need to look at the highlight of this. So what are they going to study? Okay, what are the parameters they are going to study? Those things. So coming to the next one. So here, any abstract, if you look into any abstract dealing with introduction, that's what first part. Here, if you look into this paper, so here concentrate on injection, injection of a fuel. So by using combustion concept, there is another new concept which is introduced on 92, but coming to exist in 2010 onwards. Okay, so it is a recent paper. It is 2022 papers. So here, if you look into why we look into this, so there is a long, or you can say linear. So you can say vertical smoke. You can say combustion pressure you are going to get like this. That is why I am just taking the picture of this. So this is what. The way of combustion, what you are going to get during a spark, or you can say as a fuel injection, both combination ignition system. So here, this is what regarding, I don't want to discuss more on this because of time. Okay. So but looking into this particular injection method, so here it's a direct injection of hydrogen with respect to spark plug. Because of combination of this, you are going to reduce the oxidation. So oxygen oxide. So nitrogen oxide. So and why you are going to reduce the nitrogen oxide? Because of this environmental issues and as well as where a lot of limitation related with respect to this. So coming to this method, coming to direct injection of and as well as spark ignition system, there are a lot of advantages over here. That's what highlight of this paper. This is what conclusion part of this. So it's high thermal efficiency. Nothing but if you are looking to parameter called ignition as well as spark, if you are going to combinedly adding by some angle with respect to angle as well as with respect to some pressure with the compression ratio, then what happens? The thermal efficiency coming to increases. So, but however, there is a cooling losses, but you can avoid this by using other parameters and nearly zero emission. Okay, you can achieve from this particular paper. So, coming to indicate thermal efficiency, they achieved almost 52.5%. So, compression ratio they used. Okay, so compression ratio they use, but however they are going to add a spark off of the compression stroke. So supercharging. So see in this particular paper they discussed that supercharging is avoid, or you can reduce, or you can say coming to reduce nullify. Okay, not nullify. You can say you can control the knocking. Okay, and the parameter used in this paper is first is air fuel ratio and injection time increases the power output. Okay, this is regarding a particular paper. So coming to here, so why I am just use this particular logo, because one company so developed the engine. Okay, so that's what Nissan company. So this company developed an engine, it's already a 5C engine, I think, but they modified the engine. So coming to here, University of Tokyo City University is given as spark plug for this, nothing but they introduce spark plug because the fuel injector and spark plug combining together, they are going to operate the, so just like I think diesel engine you have fuel injector, but in petrol engine you have spark plug, combining together they are going to operate this particular engine. That's what direct ignition system. So here I don't want to discuss here. Actually I planned a lot of things related to angle and all those things. What are the parameters influencing and Q1, or you can say theta 1 and theta 2. So preferably they optimize the theta 1 as 32 degrees. Okay, nothing but whatever the angle between a spark and as well as fuel injector. Okay, they optimize this as well as this. Okay, because of time constraints, I'm going to skip over here. So as it is a fuel injector, okay, fuel injector. So hydrogen, as you know that last few years, 3-4 days, we are discussing on hydrogen. But fuel injector is a major rule, okay, and you are unable to use the same type of fuel injector for this. So because of low density, as I said that. So many of the parameters. So here there is a separate fuel injector designed by Tokyo City University. So here, so there are 5 nozzles holes. Whatever the diameter is going to start from 0.3 to 0.4, but here they mentioned 0.4. So if you look into this, these are the technical specification of engine, and these are technical specification of a fuel injection system. So and this is regarding whatever the various system which is connected to analyze the engine performance. So take an example, you required compression analyzer, you required smoke analyzer, everything. Okay, so that's what, because of time constraint, I'm just looking into only the highlights. So this is a compression ratio what they used in this particular research. Okay, they optimized as 20:1. So behind that they used the various compression ratio also, but however they won't get proper result. Okay, so result is not up to the mark. That is why they skipped those results and they are given only up to 20:1. So this is what schematic of experimental setup. This is schematic. Okay, they use dynamometer instead of a real, or you can say practical oriented machine. So these are the results. So if you look into these results, so here that's what I just discussed you here. They used up to whatever the crank angle of up to 25, but behind 45. So they doesn't observe that. Okay, nothing but there is a degrees of COP with respect to 45, and you can say start of ignition. Okay, so it is coming to decreases further. That is why I just they not use the graph behind this limit. So and they analyzed with respect to various cycle, but however to analyze only I can say range. Okay, range of whatever COP intensity. Okay, they come up with this particular, and they observe the peak, and by using data analysis they have some data. So again I am unable to share this data because of time constraints. But however, okay, so I'll just skip these words because of time constraints. I'll just look into only yeah. So if you look into this, they observed that ignition duration between this angle, so you are going to get optimum, and you can say better burning or combustion. So further, if you are going to behind this, there is an thermal efficiency coming decreases as well as other parameters. Okay, coming decreases after this range. That's what the observation of this. Okay, this is the best optimized ignition duration. That is why they use this paper over here. So coming to the last slide, because I'm skipping all the slides. So coming to here, as I mentioned that they are going to look at they reduce the NOx. Okay, so looking to hydrogen with combination of spark and ignition. So here what happens, you can avoid the knocking. Okay, not to the level, but you can reduce it. Okay, you can reduce maximum extent. That's what first conclusion. So another conclusion, so thermal efficiency coming to increase, okay, up to 53% compared to whatever other optimization. So here 20:1 compression ratio they used in this particular paper, and as I discussed you, by using supercharging, okay, you can avoid hydrogen oxide over here. So by using direct injection and as well as spark plug, particular parameters. So this is regarding just because of time constraint, I'm skipping over the conclusion also. Fuel cell and electrolyzer application for real-time applications and development of the gas diffusion layer. So development of this is the heart of the any fuel cell electrolyzer performance. So followed by I'm going to design and development of a prototype PEM fuel cells as well as the water electrolyzer. So this is the followed by I worked on this development of flexible electrodes for supercapacitor application. This is what I done in my PhD and postdoc study. So what is the idea to start this startup? So any CSR labs or academic institutions, everyone is start working on the basic R&D and they will get the fund and in-house funding or get the funding from the government organizations and industry, and they will develop the small prototype at lab scale and followed by they optimize the lab scale product at the product. Then that particular industry is looking they take the technology from the particular organization, whether it is IITs or CSL labs or academic institutions or anything. And industries look for the market ready product. So industries always, they will work for the enough investment. So once the technology is transferred from industry, from organizations to industry, so these things to be needed. The yellow color mark, first you have to design fabricate the some small prototype and testing and optimize the prototype and to do the field trials at a customer location as well as upgrade the design. And you can finally work on the techno-economic evaluation. Then it will go for the market ready product. The best example is EV batteries. Now what they are doing, they will procure the single cells and they assemble the batteries and they are testing with their labor. But now in CSR labs or some of the secret, they transfer the technology to the various industries. Now they are developing each single cell and they are testing and finally they will assemble the pack and they will do the final economic evaluation. So the main drawback in India why you cannot make this lithium-ion battery means from China we are getting nearly 80 rupees to 180 rupees we are getting one single cell, where if you make the same battery in Indian condition it will cost nearly 370 to 410 rupees. So that is the techno-economic evolution, at present it is there. So these are all needs to be done. So with this idea we have more than 13 years of experience in this hydrogen field. So we start this company and we are working on the yellow marks. We are not doing any basic R&D part and we are not the supplier to that we are not the manufacturers. So we are on the process development. So like it is a technology readiness level. At the end of this slide I will explain what is the technology readiness level and all these things. These are the organization details and this is our core expert team. For Dr. K. Nagamayesh is the CEO and co-founder and he is a strong vast experience in this development of electrolyzers and fuel cells. And he is a Sarda Prasad, ex-Reliance employee as well as Nearest India Limited. He is more than 3 decades of experience in this process equipment and myself is Dr. Ramsankar. So initially we started this startup as we know something. So we approached to the client and it is not the thing, they are not like the things, but we cannot get any fund. Fund is, or money is the oxygen to survive the company. So for that purpose, we are approached to the R&D process and begins with understanding the unique requirement of each client and identifying the gaps in the existing market. So based on that, now closely we are working with more than 10 IITs and a few CSR labs and industries in India. So this is our core areas and at the end I will tell. So overview of my presentation. So in the overview of my presentation, I will give you the basic introduction of what is nanotechnology and followed by what are the existing electrochemical energy storage systems, not only fuel cells. So what are the overview of the electrochemical energy storage systems and followed by what are the basic catalyst materials. Across the globe people are working on that and its application point of view and what are the upcoming technologies for the next 3 to 4 decades, what it is the upcoming technologies are there and what its challenges we have to overcome and followed by so what activities we are doing with various organizations at the end of it. So it is a nanotechnology, is a well aware of these things. These are the nanomaterials. Why? Because if any catalyst, it is on the surface of the material, it has to be exhibit more active sites. So as much as you have to decrease the size and the number of active sites will be increases. That is the crucial for the electrochemist, as a material chemist. So where for this purpose the nanotechnology started from 1959 and till date. And why we came to this field of this nanotechnology means in 1999 when I started in 2010 and 2011 my research. In 2010 the graphene is discovered and they got the Nobel Prize in the 2010. And followed by one of the professor from Pulikalajang. He is an Indian and he stayed in that Texas University. He worked with Nizama who invented this carbon nanotube. There he is the guy, he is introduced this field to me, the overview of the carbon nano materials. So with this one, I started my career with the synthesis of this graphene nanomaterials and single wall carbon nanotubes and to support to the various noble metal categories. So this is a overview. And this is the types of electrochemical energy storage systems. So this is an overview. Generally the electrochemical storage systems are mainly classified into 4 types. One is for batteries. In that batteries, lead acid battery, lithium ion battery, and in lithium ion battery there are 4 types of the lithium cobalt oxide, lithium manganese oxide, lithium iron phosphate, and nickel manganese cobalt battery. And there is one more batteries are called flow batteries. These are the upcoming technologies along with the lithium ion batteries. And fourth one is the zinc batteries. And it is come to the fuel cell part, low temperature fuel cells and high temperature fuel cells. In upcoming slides I will brief about what is the fuel cell, what is the components, and what is the types of fuel cells, and what things to be achieved to bring into this fuel cell into the commercial applications, and the electrolyzer part. So this is across the globe, the people are going this electrolyzer part like PEM water electrolyzer, alkaline electrolyzer, and solid oxide electrolyzer. And the next one is a supercapacitor. What is the types of supercapacitor and electrical double layer and electrochemical double layer. So these are the overall electrochemical energy storage systems.
Then there are gaseous fuels are there, biogas is there, liquefied petroleum gas is there, methane is there, producer's gas, then we have hydrogen also. So today we are going to concentrate more on the hydrogen. Then for CA engines also we have vegetable oils like jatropha, karanja, coconut oil, etc. So they can be used in raw form, that is directly as the vegetable oil, or esterified form, that is biodiesels or biofuels. And ethers also we have diethyl ether, dimethyl ether, MTBE, and alcohols also are used in CA engine. And similarly, hydrogen is also used in CA engine, not in the direct way, maybe in a different form or different method. Okay. So I'll explain what are those things. So why we look at hydrogen nowadays? Mainly because it is a very simplest element in the universe and most abundant in the universe and third most on the earth. That is one of the reasons. And very important thing is this one. It is clean burning and eco-friendly. See, it doesn't have carbon atom, so there won't be any formation of the carbon products, okay, carbon dioxide, carbon monoxide, all those things. So therefore nowadays we look at the carbon footprint, so this will be very useful. And this can be produced from water using renewable energy sources. Cannot be directly, but we have to use solar energy or something which will be very abundantly available and cost effective also. So using those things we can produce from the water very conveniently, and water is available, so it can be produced continuously, that is in the renewable nature. Okay. So the use of hydrogen vehicles is done in 2 ways, that is in the fuel cells, they are used. So fuel cells are right now they are highly efficient, practically zero emissions, noiseless operation, but they are very, very costly. At present they are very costly. Then hydrogen in IC engines, it is easy to convert the existing engines to operate on hydrogen, and good drivability is possible and low cost because not much modifications are required, so we can directly use. But the problem are these things. So problems like backfiring and NOx emission, that is the nitric oxides emissions, and knocking is also knocking in the sense the rate of pressure is very high. So these are the problems. So we try to address these issues in our experimental work. So we did the experiments mainly to address these issues. One of our MS scholar did this work. So hydrogen in SI engines can be used both in CA engines as well as in SI engines. Okay, in CA engines as a conventional, in SI engines as a conventional fuel. That means instead of using petrol, you can directly use hydrogen. Only problem is hydrogen, since hydrogen is having a high self-ignition temperature, it may be difficult to ignite, okay, by compression ignition. So therefore, by spark ignition with high spark energy, we can easily ignite it. And in CA engines, with it can be used in dual fuel mode, maybe with biogas in addition to biogas, or we also tried later in HCCA form. That is very efficient. Okay. And before using any fuel to engines, you must look at the properties of them. So these are some of the properties, and they are compared with to the gasoline. Okay, you can see here some of the properties are highlighted here, which are very important. For example, density you take, in terms of volume, it is very, very low, 0.083 kg per meter cube. Whereas gasoline, you see it is 4.4 kg per meter. So you need to store huge amount of, or you need a huge amount of storage area or storage volume to store the hydrogen in order to use it in any system. Okay. Then other thing is the flammability. Flammability is very, very wide. You can see 4:1 to 75:1, whereas gasoline is 1:1 to 7.6:1. That means it can burn as a very lean mixture and it can burn as a very rich mixture. So that is the one of the advantage as well as disadvantage. Then you can see the burning velocity. It is almost 6 to 7 times higher compared to the gasoline. You can see here 2.6 meters per second, and whereas this is 0.37. So it burns very fast. Then ignition energy is very low. Ignition, that means in order to ignite the fuel, you need very, very low energy. So compared to, you can see gasoline, it is almost 100 times lower. So that means very small spark is enough. That is a switch. The switch spark is also enough to ignite the fuel, hydrogen basically. And auto ignition temperature, you can see it is very high compared to the gasoline. So therefore, it is very difficult to use it in compression ignition engine. So we need to go for only spark ignition engine. Okay. So then calorific value on mass basis, it is very high compared to gasoline. It is almost 3 times. But by volume, it is very low. That is the main problem. You need lot of hydrogen in order to produce the same amount of work, same amount of power what gasoline or diesel is producing. And apart from this, it is not shown here, there is one more important property of the hydrogen. It's very dangerous. Okay. It can burn very fast. You can see here the laminar flame speed is very high. Okay. And it burns with colorless flame. That is most dangerous. So hydrogen air mixture will have no color in the flame. I mean, if in this room, if the hydrogen is burning, no one sees it is burning. That is the most dangerous thing. Okay? So if the LPG is burning, you will see green flame. If the kerosene is burning, you will see red flame. Diesel, petrol, anything burning, we will see there is something is burning. So this is very dangerous. It burns with colorless flame. And burning is very fast. From that end to this end, in a microseconds, everything will burn. So you must have heard about the hydrogen bombs. So this is the concept. Okay. So that is the advantageous and disadvantageous nature of the hydrogen. Then coming to the experimental study, so there are very important things we have to look into before using hydrogen in the engine. Okay, when we are using engine, as I told, it burns with colorless flame. If there is any leakage, it can leads to a lot of fire accidents. Okay, so that's why when we are using hydrogen in the IC engine, that is hydrogen IC engine works like a hydrogen bomb. So we have to be very, very careful. Any small leakage is very dangerous. And another problem with hydrogen is it is very light, you know, H2 is very light. So it always goes up. It will never settle here. It goes up and it can catch fire. So that is also another problem. So we have to be very careful as far as the leakage is concerned. And another thing I told is it can catch fire with very small energy, very small ignition energy. If there is any spark in the electric line, if there is any switch in the electric line, if you just switch on, it will catch fire. So these are some problems. And also, when you are supplying the fuel to the engine, always there will be some accumulation of the fuel in the manifold. That accumulation, suppose if there is some exhaust gas is mixed to that one, that can catch fire and it can explode in the inlet manifold itself. That is called backfiring. So this backfiring is one of the problem, and also because it burns with very high flame speed, the rate of pressure rise will be very high. So if the rate of pressure rise can go more than 15 bar per crank angle degree, so that is very high. So then the engine will be operating, the engine will be subjected to a lot of vibrations. So smooth operation will become a problem. So these are all the issues with the hydrogen. So look, keeping these things in mind, so we made an experimental setup. Okay. For that we selected an engine. It is a single cylinder water-cooled spark ignition engine, and it was 0.5 liter engine. Compression ratio, original compression ratio was 9:1 for the petrol, and rated power was 30 horsepower at 2500 rpm for gasoline, and rated torque was 32 Newton meter at 2200 rpm, and BSFC was 300 grams per kilowatt hour for gasoline. Now there is another issue also, as I told, on volumetric basis, the hydrogen will have a very low energy. Okay, and also since it is in gaseous form, when you supply hydrogen to the engine, the equivalent amount of air has to be displaced. So there will be volumetric efficiency. So when volumetric efficiency goes down, for the same capacity of the engine, the power production will go down. Okay? We will see those things later, how much it is reducing, etc. Now before using it in the engine, we have to do some safety aspects we have to take into the account. So in order to avoid, we are always supplying hydrogen from a cylinder to the engine. There are chances that the fire can go back to the cylinder and cylinder can explode. So therefore, we have to see that even if there is a backfiring, that fire is not going to the cylinder. So for that we kept one water trap and a wire mesh type of flame arresters. So if the fire comes back, it will be trapped in the water trap. I think water trap is nothing but the cylinder, from the cylinder when the hydrogen is supplied to the engine, it is bubbled through the water, and when the hydrogen comes out, it is taken to the engine. So not direct connection, so there is an indirect connection. And also it is passed through a wireless mesh, that is a wire mesh type of flame arrestor. You know, there is a flame quench distance. Okay? Flame quench distance for every flame. That means the flame, if the diameter of the tube is lesser than flame quench distance, then flame cannot pass through that because of flame quenching. So we made us the wire mesh type of flame arrestor will be having holes smaller than the quench diameter. So thereby the flame cannot pass through. So these two are there. Then we also had one handheld hydrogen leak detector. If there is any small leakage, even 5 ppm leakage is there, it will give you the beep sound so that you will understand the issue. Then crankcase, you know, in all the engines there will be a crankcase. So because of blow-by, the fuel can accumulate in the crankcase, and that also can catch fire. Okay, so in case of hydrogen. So for that we need to have a crankcase ventilation. There will be a small hole will be done, and so that it is not accumulated, it is exhausted to the atmosphere of. So this is the water trap used for the to prevent the fire back. Okay, so you can see here, the steel one is the supply to the. This will be containing water. Okay, this will be containing water, and supply will bubbled through the water, and then at the top it is taken to the engine. So that is the water trap type of flame arrestor. And this is the wire mesh type of flame arrestor. Okay. Here again supply is done from the bottom or top, and here in the center there will be a small wire mesh, and it will contain the holes smaller than the punch tap. Okay. And this is the hydrogen cylinder. So to do the experiment, we use the standard hydrogen cylinders available in the market. So these standard hydrogen cylinders, you can see, they are available at 140 bar capacity, 40 liters. The hydrogen cylinders are available at 40 liters with 140 bar. So now at 140 bar, we use a pressure regulator to reduce it to the required one, maybe at 5 bar. That's what we have used. And after reducing to 5 bar, then it is passing through a hydrogen mass flow meter. So in order to measure the mass flow rate of the hydrogen. And this is the instrumentation. We have a centralized instrumentation in our laboratory to measure the NOx emissions. That is the chemiluminescence detector. That is the principal. And HC is also available in this one. That uses the flame ionization detector principal. Okay, these two are very important for any IC engine research. Okay, so the exhaust samples will be supplied to this one, and they will measure the. This is the 5-gas analyzer used to measure CO, CO2, O2, etc. It can give 5 gases measurement, and that works on NDIR, non-dispersive infrared principle. Okay, and this is the dynamometer, the eddy current dynamometer. This is the engine. That is the 0.5 liter engine. Okay, this is connected to a dynamometer. Here you can see water trap flame arrestor, wire mesh type flame arrestor, and the pressure gauges, etc. And this is the inlet manifold. Okay, this is the drum, air drum to reduce the flow fluctuations. Okay, and this is the inlet manifold. You can see here to the inlet manifold, hydrogen is supplied directly. Okay. And here you can also see the carburetor that is used for the petrol. To run the engine, and all our results are compared with the petrol engine baseline reading.